Yeah, I said, well, how do we care about motion and movement, right? Well, a common one is when we're looking at velocity, and let's say I've got some velocity represented by this arrow. We're traveling at like 60 kilometers per hour. Now, in reality, it's not only the vehicle's individual speed or velocity that is affecting it, right? There's often external forces. So, like a common question would be like, hey, what if there's a wind going in the same direction, right? A big gust of wind, I don't know. Maybe if it's like a boat or something like that, it's probably a bit more realistic, right? So the boat's traveling at 60 kilometers per hour. We've got like a tailwind. Is that what you'd call it if it's coming from the back? Yeah, or a tailwind that's going at 20 kilometers per hour. We can think about this as adding the two vectors together, like the total velocity would just be 80 kilometers per hour, right? This can also work against you, yeah, because if you've got a headwind, right, it's, coming in your face, and yeah. I mean, there was this one time I remember in Hawaii, there was like this mountain, it was so high up, and literally, like if you just stood still, you would just be pushed back, like so. Sorry. So is this what happened at GQVet as well? Or?
It was pretty crazy.
Yeah.
But I don't know that you get pushed back.
Yeah.
I did get knocked over a few times.
Like you're just kind of doing stuff and then like just big gust of wind. Yeah. We were actually playing. I actually remember we were playing Ninja Destruction in this wind situation. So that made things very interesting. We were trying to
off the cliff and would land 20 meters behind you.
Well, you tried to throw it off and it would just go backwards.
Yeah.
That's hilarious. So yeah, let's say we're on this Duke event situation, and we're going 60 kilometers again in this direction, but then we've got this headwind going on.
Right, so this is pretty much what we learned maybe like first term of year 11.
I guess so, yeah. So.
This is why I dropped physics.
Oh, is that why you're dropping extension as well? Or is that?
Next extension thing didn't go well. This one didn't go well.
All right, cool. So total velocity, you can just add them together. There's a problem with this. Have a think about what the problem might be there.
10 kilometers per hour.
Just like unit conversion is what we're interested in extension one, right? Think about let's go to Callum's mountain example, right? Do you think this would be an accurate representation of what's going on? Are there any problems with this representation?
You just got to draw a rock. That's the only wrong thing with Callum.
What's the difference between this representation and what happened with Callum on the mountain? Is there any difference? Right, so now obviously we don't look at third dimensions in this course because we're limited to 2D vectors, right? But what we can do at the very least is we may not look at 3D situations, but we still look at more applied situations because this is literally, is this one dimension? There's like left and right. I don't know if you'd call it one dimension. Like 2 dimensions, there's another aspect, there's an up and down, right? We'd look at, for example, a Cartesian plane. There is a situation where, I can not only move left and right, but I can go up and down. That opens up to a host of more kind of problems. So let's not make it so contrived in the sense that, all you're doing is going left or right. You've got a tailwind or a headwind. Let's look at a 3D situation. Let's look at this example. We look at a plane. Probably not the best time to be a plane at the moment, traveling, but we're looking at a plane, right? I heard they grounded all the international flights for. That's crazy. Like, it's just, man.
Is it crazy or is it?
It must be bad if the airport is shut.
So the airport's actually shut, or?
Well, Qantas gave up, didn't they?
I can come back to overseas.
I think there are still some essential flights running.
Aren't like a bunch of the states closing their doors now?
Yeah, well, if you want to travel into South Australia, for example, you have to declare that you will self-quarantine for 14 days, except unless you're like a freight traveler or like delivering goods, or you like live in the border on one side and you're working on the other side. Yeah, so it's pretty crazy at the moment. Anyway, so we're traveling and this is why this kind of problem is different. This is a velocity type problem. Okay, velocity. I said there are a few different types of problems you can ask, and this is a velocity type problem. And notice what they give you. Because before, when we were given the vectors, we gave them as like coordinates, like A and B, right? I said, hey, I've got this vector, and I can give you its horizontal and vertical components, A and B, okay? But this time, we don't have any of that. What do we have? We have that it's traveling at 250 kilometers on a bearing of 40 degrees, right? So when I looked at that, I'm thinking, okay, well, this is where we have to be careful because we know that north is in this way and it's a bearing of 40 degrees here. So like that.
Now, are we looking down at the plane or up at the plane? Or
Well, we usually do it from like a, whatever the direction is. So this is a true kind of bearing, right? So the bearing, you can think of it like a bird's eye view. This is north. And so the plane is traveling in this direction. Yeah, does that make sense? I might get rid of that because that's just a bit messy. Okay, cool. But then remember, a westerly wind, so a westerly wind is from the west, okay? The westerly wind, that sounds like a musical of Oz kind of things. All right, so from the west, where's that? Right, well, it's from the west in this direction. And how do we actually want to think about this situation? Well, what's happening is that, think about it like this. This is a more realistic example now because our plane's not just traveling in one dimension. You can travel in this direction, you can travel in that direction, but the wind is still considered as a vector which is adding on to that, right? So it's a westerly wind in this way. And what's helpful is, yeah, okay, the wind is kind of all over the whole thing. But if we want to think about how this affects the plane, where should we draw our vector? Yeah? Like would I draw it here? Would I draw like these are all happening right now, right?
So it's from the west.
It's from the west, that's right.
There's
Yeah.
a west. So, okay, so from
Put its butt to its head.
From its butt to its head. I can't say I've heard that one before, but I'll take it. We usually say tip to tail, but butt to head if you prefer that. All right, so in this way, yeah? And it's 55 kilometers per hour. And so we think about, all right, if this is my plane, it's traveling this way, but the wind's also affecting him, what's the actual speed and bearing of the plane? Well, in this situation, what's actually going on is that he's not just traveling this direction now. Because the wind's influencing him, we can think about this as the addition of two vectors. Let's use a different color. We can think of it as like this. Would you guys agree? Yeah? Once we've done that, what I can do is I can think about, all right, how do I describe this vector? Think about what we just looked at. What kind of operation did we do with the vectors? Yeah, and so this idea of tip to tail, Harry, is we arrange them like this. Another way to write this red vector, because we're saying, okay, vectors are the same if it's tip to tail, is if I call this vector u, and I call this vector v, I can call this red vector over here u plus v, okay? So this applied situation involves you having to construct this graphical representation and also recognize that I have to add these two vectors together. The other problem though is that we don't have our two coordinates here, A and B. So what exactly am I adding?